Hi, this is a quick video tour of a custom end stop I've created for the Festool LR32 system. This particular end stop is designed for use with Blum hardware and the Blum Process32 system. The Blum Process32 system requires offsets of 46.5 millimeters and 62.5 millimeters, and that is what this end stop supports. This end stop was designed by me in Trimble SketchUp and was printed in 3D by Shapeways. The material is what Shapeways calls their strong, flexible plastic. It does appear to be quite strong. It has kind of a sandy or grainy feel to it. I don't think there will be any concerns with durability or just general strength if it's used appropriately. Unlike the standard Festool LR32 end stop, which is metal and threaded and uses a single knob, again, this is made out of plastic, so the mounting hole in the center there is not threaded, and as a result, I use this hardware here. This is a stainless steel M6 knurled knob, and then an M6 knurled nut for the bottom, and they secure through the guide rail, and it works pretty well. So let me get this hooked up to the guide rail and let's see how it works. Okay, I've got the end stop installed on the guide rail. Again, because this end stop is plastic and the mounting hole is not threaded, I'm using these screws, this M6 screw and this M6 nut top and bottom. The reason I'm pointing this out again is because, just as sort of an FYI for everybody, the distance from the bottom of the guide rail to the bottom of this knurled nut here is almost exactly 1 inch. So any material that is less than 1 inch thick is going to have to be hung off the edge of your table or your workbench in order for everything to lay flat. The end stop installs exactly like the standard Festool LR32 end stop. You put the locating pin in the right hole, and you've got the desired offset, in this case 46.5 millimeters, up and out. So it works just like the regular Festool LR32 end stop in that sense. The other thing I want to point out is that the labeling on the side here, as well as the dimensions, are 3D printed, so these are not labels. I'm sure you can tell that in the video, but they're not labels, they're 3D printed, so they're not going to wear out or wear off or anything like that. The other thing that you may have noticed about the end stop is that in addition to the 46.5 millimeter offset, I have this label here that says 2H, which stands for 2 holes. The reason for that is that in order to get the 46.5 millimeter offset, you have to count 2 holes into the guide rail. So in this case, if I pan the camera this way, the correct hole for a 46.5 millimeter offset is going to be 1, 2. It's going to be this hole here. That's the one that we want to use to get a 46.5 millimeter offset. So let's see how this works. Okay, this is kind of a weird angle here, but I've got the router on the guide plate, on the guide rail. Everything has sort of been set up and I'm pretty much ready to route at this point, or ready to drill the hole at this point. The thing I want to point out here is that the hardware that I'm using, this M6 screw here has a head diameter of 24 millimeters. It's only 1 millimeter more than the standard screw that's used in the standard Festool LR32 end stop. And as you can see, there's really no interference, and it looks very nice against the guide plate. So just wanted to point out how that works. Okay, I've switched to the other end of the workpiece here just for some better light for this demonstration. I've got the end stop installed with the 46.5 up and out. I've counted my 2 holes and marked it. I've got the guide plate indexed properly, so we're ready to drill a hole. So here we go. Okay, so you can see the hole that I've drilled. This is a moment of truth. I've got my digital calipers out. I've got them set here. You can see, if I can get it to focus correctly, to 46.5 millimeters. I've got the screw set. You can see the edge of the piece of the wood. Let's line everything up and see how this comes out. So we've got this lined up here on the edge, and we tip this in. And as you can see, it's right about dead center. It's probably hard to see in the video, but it's right about dead center in that hole. So I think this is exactly or you know, really, really close to 46.5 millimeters. So let's go ahead and check the 62.5 millimeter hole. Okay, I've got the end stop set for 62.5 millimeters here. One thing I want to point out is that the 62.5 millimeter setting has or requires 3 holes distance to be the right setting. So you can see this is the locator pin here, and then we've got 1 hole. It's a partial hole. You can see the guide stop through it, but it's 1 hole, 2 holes, 3 holes. So I'm going to erase my mark here, and I'm going to move it over here, and then I'll put the guide plate on it and drill the next hole. Okay, moment of truth time again for the 62.5 millimeter hole. I've got my calipers set at 62.5 or close to it, and I'm going to line this up like I did the last time. So I've got the edge of the wood down here, and I drop the tip of the caliper there in the hole, and you can see the tip of that caliper there is pretty much bang on in the middle of the hole. So again, 62.5 millimeters, you know, either exactly or very, very close to exactly. One thing I want to point out here about the 62.5 millimeter hole, for demonstration purposes, I drilled this as a 5 millimeter system hole. In reality, and you'll see this in the Blum Process32 manual, but in reality, the 62.5 millimeter setting is used for the cup hinges. So you would typically be drilling the 62.5 millimeter setting with a 35 millimeter bit. Again, this was just for demonstration. So there you have it. That's the custom LR32 end stop for Blum hardware and the Blum Process32 system. Thanks for watching.